Hey folks, in today's TypeScript tip, we're going to show you how you can use tuples to limit array length inside of your types. We can see here on screen, I have a Pokemon interface that has a name property and a types array here, which is an array right now of elemental types. Now, if you're familiar with Pokemon, there's a bug in my code right now because my Charizard X Pokemon currently has 3 types, and that's actually a mistake. Part of the mechanics of Pokemon are that you can only ever have at most 2 elemental types at any one time. So how do I inform TypeScript about this constraint? I can actually take the types property here on our Pokemon interface and change this to be a tuple. What I have here limits the array size to 1. We can see Charmander is fine, but Charizard is not, but he should be. So let's actually make our types a union here of either a single elemental type or a tuple of 2 elemental types. And now we can see Charmander's fine, Charizard is fine, and Charizard X is not. And this is actually what we want, because Charizard X's type, as everyone knows, is just Fire and Dragon. The last time we talked about tuples, I forgot to mention one important point. Tuples don't actually exist. Well, they exist at the TypeScript level, but by the time we transpile it to JavaScript, a tuple is the same at runtime as any other array. So tuples really just exist at the TypeScript level in order for us to get the right level of specificity for the typings of our array. Let's take a look at this example. Here we see our tuple, and we can see that it has a type of a string or number array. This means when we look at the type of this name value after destructuring it, we can see it's a string or number, and value the same way is a string or a number. Now we can go a little too far with our specificity here by adding as const. And this will say that tuple has a type of the specific string Zach followed by the specific number 7. And here our name is specifically the string Zach, and our value is specifically the number 7. But that's a little too specific, and this is where we can use tuples. So I'll add a type definition here to tuple that it is a string followed by a number. Now we can see the tuple matches. Our name is a string and our value is a number, just like we wanted. So let's say we have 2 types, and they should be roughly the same as each other, only one should be missing an ID field. The solution on screen actually works fine until we want to do something like add some more properties to one of our interfaces. Now I need to copy whatever change comes over and manually keep these in sync, and we can do better than that. One thought that may come to mind is exporting our request body interface here. In this case, we could import that request body from our other file. And we'll say interface Pokemon extends new Pokemon request. And here we can add an ID field. Now we've tied our Pokemon interface to our request body interface, which actually works, but I don't love it. At least in my mind, it seems like the Pokemon interface should be the base interface that we extend. But how do we do that if we're trying to remove fields from the interface? Thankfully, there's a TypeScript utility for just that. Let me back out my changes. And over here, rather than an interface, we can now export a type equals omit. And here we can pass in our Pokemon interface and then the field we want to omit, in this case, ID. At this point, we can see our Pokemon request body matches, and if we make a change like so, our request body stays in sync. And that is the Omit utility. Hey folks, today I want to take a look at string union types and how we can use that to enforce that matching properties exist on an object literal that we're creating. Let's look at the example I have on screen. We have a union type here, color, that is red or blue or yellow. And I have 2 different ways of creating an object here. I want to enforce that every string inside of my union is present in the object. The first way we see right here, we're telling TypeScript that we can index the object with any string X, and that will map to a number. We can see here, we happen to have strings red and blue that match our color type union, but we're missing yellow, and TypeScript isn't warning us about this yet. So we can change the type of our index here inside of the object to say it's K in color. And this is telling TypeScript that any type parameter K inside of our color union type must be present inside of our object. And you can see right now, it's upset at us because yellow is missing. We can add the quick fix here. That will add it in for us. Same thing with the record type down here. This is actually a TypeScript utility meant to do exactly this, but just with a little bit nicer syntax. We can see here, same thing. We're telling TypeScript the properties should be any string, but as soon as we narrow this down to a color, we start getting the error here that yellow is missing as well. So that's how you can enforce all your union types to be present as keys inside of your objects. Catch you all next time.